Okay. Okay. So what I tried to do, I tried to draw different types of beams, different types of frames. So you can see at the top we have um, three beams, and then we have three frames or two frames. Okay, and I'm trying to go and do the loading now. So I'm assuming that there is a UDL here. There is a UDL. There's a UDL. And then for the frame, there is a UDL here. Okay, and we try to draw the bending moment diagram, but before drawing the bending moment diagram, we said we should know whether the support is continuous or discontinuous, if you remember. So by now, you shouldn't have a problem in figuring out which one is continuous, which one is discontinuous. So if you see here, this is discontinuous, this is discontinuous. This is continuous from both sides. This is continuous from both sides. This is continuous from one side. This is continuous from one side. Are we clear about this one? Okay. We just started this one. We just started. We didn't explain anything before. Okay. So once again, we are trying to draw the bending moment diagram. First thing we said we are going to know the different types of support. So after that, what we are going to do, I'm going to draw that there is a support here, draw that there is a support, and then this support once again. And then I'm drawing here that this is fixed and this is fixed. Now, if you remember, we said because of discontinuous or non-continuous or discontinuous here, support, moment is going to be zero, moment is going to be zero, and then we are going to have the parabolic shape. Now, because this is continuous, both sides, then we have that cantilever on this side, that cantilever on that side. Same here, continuous both. Okay, so it goes up on both sides, and then we are going to have the positive portion. Now, for this one, it is a continuous, we say. It is continuous, but it's continuous from one side. So I just draw the bending moment in this side. The same here, I'm going to draw the bending moment on this side. So why I draw it to the right or the left, it depends where the member to the support. You will see that the member for this support, the member on the right, for this support, the member on the left. Okay, and then we are going to connect. Now, of course, the bending moment here is going to be different. The values of bending moment is going to be different. Okay, here it's full fixity. Here it's not full fixity. Okay, and we'll see later on when it comes to the software. We'll see how the values are changing. Okay, now that's not a big issue because we have talked about it already. Now, when it comes to the frame, the frame, I took one frame. I took one frame which is having a pin support, another frame which is having a fixed support. What would you do for this case? How would you draw the bending moment diagram? Any idea how would you do? Make it three spans.
Mr. Again the question. Mr. Again the question.
How would you draw the bending moment diagram? Okay, so make it three spans. Okay. So like this, you mean? Or are you referring to something else, Mazen? Okay. Okay. So the easiest thing, as Mazen said, okay, the easiest thing is to draw it in this way, where we are having now this is member number 1, number 2, number 3, and this is now number 1, number 2, and then number 3. Are we okay? Are we okay regarding this one? Are we fine?
Mister, can you repeat it once again, please?
Which one?
The second one.
You mean this one?
Yes, Mister.
So if you see, we have 3 elements. This is element number 1. This is element number 2. This is element number 3. So instead of drawing it to be 2D, I just draw it to be linear. Okay, so this is going to be number 1 now. This is element number 1. This is element number 2. And this is element number 3. Are we clear?
Yes, Mister. Thank you.
Now we want now to draw the bending moment. How will you draw it? Now first thing we'll try to go to the support. Yeah, we'll try to eliminate or try to do the easiest part. Okay. Now this support, is it continuous or discontinuous? Continuous, discontinuous. Okay. So that's not continuous. It means that the bending moment in this point is equal to 0, and in this point it is equal to 0. Are we fine? In this point, okay, it's discontinuous. Okay, it's discontinuous. What about these? These are continuous one side. Okay, these are continuous one side. So if we try to draw the bending moment diagram, okay, we have still joints here and these joints. Now, these joints, are they going to be continuous or discontinuous? The green dots or the green joints that they have drawn, are they continuous from both sides or one side? Continuous, right? Okay, so the joints that they have drawn here, G, let's say G4, G3, G2, G1, are they continuous or discontinuous? Okay.
Continuous.
It's continuous from both sides. It's continuous that there is an element here and there is another element here. One element and another element. One element and another element. One element and another element. So it is continuous from both sides. Okay. So what I'm going to try to do, since this joint is represented here now, this joint is represented here, then we have a small one here, 3, and we have here joint 4. Are we okay with the joint? Joint 1, joint 2, joint 3, joint 4. Are we okay? Are we fine? Okay, so what I'm going to try to do, I'm going to try to do that there is a cantilever as we used to take. Okay, I'm just going to draw that there is what you call, there is a cantilever. Once again, here there is a cantilever. Okay, we are going to join between these that there is what you call, there is a parabolic going down. Same thing here, it goes up. So here and then here, here here, and then here. Now, in this scenario, do we have any loading? Do we have any loading in this particular region? Do we have any loading here and here? No loading. So if in case of no loading for bending moment diagram, you should know already that it goes to, instead of being parabolic, it goes to be linear. Here there is no load, so of course it goes to zero, straight to zero. Are we fine? We are talking about bending moment now, not shear force, whether it's stable or not. The same thing here. Okay, there is no load, so directly it goes to the zero. Are we fine? So if we try to draw the bending moment diagram, okay, if we draw the bending moment diagram now, we take it a little bit this way, and we try to draw the bending moment diagram one time for this frame. Then I would say that the bending moment is going to go like this, which is for this portion. Are we fine? Are we okay? For the middle span, what about the other span? The other span, it goes to zero. It starts from zero at the support, and then it goes straight till we reach to a value of bending moment. Are we fine? In software, when you go and see it, this is just approximation. When you go and see it in software and how we are drawing it in reality, it's going to be of this way. Are we fine? So drawing it in this way or drawing it in this way, both of them are fine. Are we okay? The value of this bending moment is going to equal to the value of this bending moment. Okay, can we go for the second one now? Can we go for the second one? Now, for the second scenario, what is the main difference? Second scenario, what is the main difference? What is the main difference between scenario number one and scenario number two? The main difference was the support, right? So, for example, if I go and just erase my support from here and make it to be fixed, what will be happening? Now you will see for the fixed, if we try to draw the bending moment diagram, we say that it goes up, right? Okay. It goes up, okay, and then straight. But when it comes for this case for a frame, okay, when it comes for a frame, normally there are two ways to draw it. Either it can be like this, okay, it's linear only. There are no loops. Okay? There are no loops. So either it will be of this shape, okay. We agreed about this one. This is same. Radiate here. That this is same. Now we are talking that this is a point where this is equal to this point. Same. Okay. Now next step is this one. Now it depends on the value of moment and the value of load. We have two scenarios. Scenario number one, where it is going to be like this, where there is a moment value here and a moment value here. Or scenario number two, which is going to be like this. Okay, so both drawings are actually correct. Both drawings are actually correct. It depends, both of them are correct. Both of them are correct. It depends on the value of moment and the loading. Okay, it depends on the value of moment and the value of loading. You will see both scenarios. Okay, so if you don't have a value, both of them are correct. Okay? Both of them are correct. Okay, are we fine? It is something when you talk about it, something yes and no.
This the joints here from both sides. So one side parabolic, another side we will draw it as linear from the beginning of the joint.
Linear because there's no loading. If you return back and see.
Okay.
Normally the loading on the frames, normally the loadings on the frame are going to be gravitational forces. Normally, we didn't talk about lateral loading and wind load and seismic. So load will always be vertical down. This is a column. So the only case which will come as a UDA is going to be wind load and seismic, which we didn't cover yet. Okay. No, values will be depending. No, values are not going to be the same. Values are going to be depending on the loading. Okay. Values are going to be on the loading, depending on the loading as well. Bushra, I hope I have explained for you. You had the same question where Amira has asked. It's related to gravity forces. Dead and life load will always go down. In case of a frame, dead and life loads will go down. This is a column. It's a vertical member, so you cannot draw it as a UDA. It cannot dead and life load. They don't act to be horizontal. They act to be vertical. Are we clear? Are we fine? Bushra, just concentrate here. Now, frame. Okay, this is the frame. Frame is representing a column and a beam, right? So this is a beam. This is a column. Okay. Now, beam is a horizontal member, right? Beam is a horizontal member. Column is a vertical member. When we talk about dead and life loads, are they going down and up? Are they going vertical or horizontal? Bushra? Dead and life loads, are they going vertical or horizontal? The weights of the things, are they going down or they going to the right and left? Vertical, vertical. So for vertical, you can draw it here. Can you draw the vertical on this column? If the column is already vertical, can you draw the vertical UDA? Is it possible? So So that's why I draw it only in span number 2. Is it clear? Are we clear now? Good. Okay, good. So if you go and see here, for your frames, you will see that now what do we have? We have 2 frames. Okay, we have 2 frames. Okay. So now actually, if you go and see the same thing that we have, okay, the same thing that we have a negative here bending moment, a negative bending moment, and then we have a positive, and then we have the moment, since this is a hinge, we have a moment going to 0. Are we clear? Okay. Now, since this is these are 2 frames. Okay, since these are 2 frames, and we want to draw the bending moment for them. Now, if we see, this is my first frame. Let's say it's a ruler. This is a ruler again. This is another frame. Oh, this is a ruler. This is a ruler. Now, what happens? What we say the bending moment diagram? We say the bending moment diagram is going to be over here. Right? Are we fine? When this particular member goes down, it will push this column outside and it will push the other column outside. Are we okay? Same thing is happening here. Same thing is going to happen here. Now, if this span is L and this span is L, this loading is W, and this loading is W. This moment and this moment are not the same, or they are the same. Same moments, right? Okay. So once again, this will be pushing this side, that will be pushing that side. Now, what will happen if I try to join these together? If I try to join them together, this is my frame. Okay, this is my frame. And let's say this value of moment, I have calculated it. For example, it was 20, just for the sake of making it easier for me. Okay. Now we say that this column is going to be pushed outside. This column is going to be pushed outside as well. Now, what about this column? What about the middle one? You will see value of 20 here and a value of 20. This is my column. So one value tries to take you right for 20, another value tries to take you left 20. Will you move from your position? Are you going to move? It's going to be counteracting, right? It's going to be counteracting. So that's why when we try to draw the bending moment diagram, okay, it goes here. This column will not move from its position, and then it will continue like this. Are we clear? Are we fine?
No, Mister, no. This is again.
Once again, returning back to here.
This last steps.
No problem. Let's say that this is representing column 1, this is column 2, this is column 2, this is column 3. Now column number 1 is going left or right? Abdurrahman?
Right.
It's going left or right? Column number 1.
Left, number
Left.
1.
So this is going left now. Column number 3 is going left or right?
Right.
Right. Column number 2.
Down.
Column number 2, once is going left, this is going right.
No, it is in the same position.
Okay, so you
Center.
have a moment of 20 and a moment of 20. It means that they will counteract. You will not move from your position. Are we clear?
Yeah.
So I have drawn column number 3 here. I have drawn column number 2 here, and I have drawn column number 1. Is it clear now?
Yeah.
Others, is it clear? Okay, very good. Now, if they are not the same, okay, if they are not the same, scenario number 2, if this was 40, what will happen? What do you think? If the loading, for example, are not the same, this was W2 and that was W1, what do you think? First thing, C3, is it going right or left? C3, is it going left or right? C3. Finish from the easier one. C3. Okay, C3, if you see, we have 20 here. This is 40, this is 20, and this is 20. So you will see C3 is going to go left by the value of by the value of 20. Are we clear? C1 is going to the right, C3. C1 is going to go to the left by the value of 20. Are we clear? Okay. Now, when it comes to C2, I'm pushing to the left side by the value of 40, and I'm pushing to the right side by the value of 20. What will happen? So this is my exact position of column. First scenario, what I have done, I pushed my column 40. Okay, I pushed it 40. After that, I returned this was my 40, and then I had to return, by the value of 20. Now, how much is this one? How much is this value now?
20, Mr.
So now what will happen? This will be leaning to the left side by the value of 20 as well. Are we okay? Is it clear? Yes, Afa. What's not clear?
Mister, when you deducted the 20 from the 40, can you please repeat that point again?
20, is it right or left? 20, is it right or left? This 20, is it going right or left? Right. 40, is it going to be left or right?
Right?
The 40, is it
Right.
left or 40?
The 40 is left.
Left. So remaining will be how much? Which one is stronger? Left or right?
The left.
Left. 40 is stronger than 20, right?
Yes.
So it goes to the left. How much is the balance between them?
Oh, okay. Thank you. I got the point.
Okay. Sarah, is it clear now? Okay, good. So now, if we go and try to see, okay, if we go and try to see whatever we have done, which one you didn't understand, Bushra? This is my initial column. It has 0 movement. Scenario number 1, this column has moved by a value of 40 to the left side. So it's now minus 40. After that, I have pushed this column by 20 to the right side. So this is plus 20. Now, what is the total value? The total value is going to be minus 20. Minus is representing left, so my drawing is going to go for the 20 value. Okay. Okay, so this is symmetrical. It says for you symmetrical. That's why you don't see any moment in column number 2. Are we clear? Are we clear that why you don't see any moment in column number 2? Okay. And we said that this value of moment is equal to this value of moment as well. Second scenario, it says for you unsymmetrical. Unsymmetrical. Okay. Unsymmetrical. Now you can see that the value we have, let's say that this is span number 1, we have span number 2. For span number 2 moment, for the left side is 0.296. And then for span number 1, once again for span number 2, it had a moment of 296. While span number 1 was having a moment of 0.141. Now, how much is the balance between them? This is pushing you 296. This is pushing you 141. What is the balance? Will it go to the side of 296? Is it going to go to span 1, pushing span 1, or pushing span 2? Which one is stronger, 296 or 141? 296, span number 2, right? That's why this column has been pushed to the side, because 296 is stronger than 141. Are we clear? How much is the value? 296 minus 141 is going to give you 0.155. Clear? Is it clear? Okay. Now this is the 3D. Now doing or analyzing a 3D is going to be a little bit, analyzing a 3D is going to be a hectic job. That's why normally we do a software rather than analyzing it to be manual. Okay. Of course, when it comes to reality, it's a 3D frame. It's not a 2D frame. I have already explained for you the simple end and fixed end. If you remember, we said, you remember that this is going to be 0. This is going to be having a moment at the bottom. I think this is already clear. I spent a lot of time already in analysis. Okay. Now going for a one-way slab. We have two dimensions. Dimension number 1, and we have dimension number 2. This is long span. This is short span. The bending is happening along which direction? Now you can see or to keep it a bit simple, you can see that here it's a light blue, here it's a light blue, here it's a dark blue. If we take a section here, dark blue is representing negative value. You can see here, you can see that the values are increasing. So what does it mean? It means if I take a section, it says 0 and then it increase till we reach the maximum at the center. Are we clear? Are we clear? Are you going to draw to the short or to the long? You were going to draw it, of course, to the short, not to the long. Okay. Now you can see if I take a strip here for the long, the bending moment is different. Here, the bending moment is different. But if I go and take any portion of the short, it should give me the same. Are we clear?
Mister, the bending is not happening at the center.
Maximum at the center is.
Okay, why we don't draw the bending at the long span?
Why what?
Why we don't draw the bending at the long span? Why we choose the short one?
Because it's a one-way slab. Yesterday I have explained for you.
Okay.
Now, when it comes to one-way slab, before, not last, I have explained for you the example of one-way. Okay. I have explained for you the example of a one-way slab and a two-way slab using a paper and a ruler for those who have who have seen the explanation. And I told you a paper.
Yes, it's clear.
Once again, from here, from the picture, it's very clear. You can see if I take a portion from the long direction, you can see at any time I change the longer portion, my bending moment changes. Okay. But if I'm taking it for the shorter, it's going to be always the same. Okay. For one-way slab, we cannot say that there is no moment at the longer direction, but the proper thing to say is that we have a major moment and we have a minor moment. Major moment is going to be to the short, minor moment is going to be to the long. Are we clear? It says one-way slab because it has one major moment, that is in the short direction. You can see that the moment is changing. The moment is changing when you move in the short direction. The moment will not change. Okay, the moment will not change if I go and walk around long span. If I take a strip here, you'll see that your moment is not moving. Okay. Two-way slab. From the name two-way slab, it has two major moments. It has a moment. No, it's not. For the slab, it's not related. That's related to load distribution for the beams. But when it comes to one-way slab, the bending moment of the slab is not really related to the support, related to the beam. Okay, now when it comes to two-way slab, we have two major moments. So what happens here? I'll draw one moment. I took one line here. I have drawn one moment for the X, and then I have taken another moment for Y. Okay, so we have something called MX and we have something called MY, and I have explained it in the last session as well. Okay, to make it a bit clearer for you, take a paper and take a ruler. Paper tends to be something similar to a two-way slab, because of the dimensions. You can see that you can bend it in two directions. Try with the ruler, you will see that the ruler can be only bent in one direction. Why? Because one dimension is long, one dimension is short. I have already explained this one in the last class for you. Now going for this particular problem, Now this one is a two-way slab or a one-way slab? According to you, this one a two-way slab or a one-way slab? Two-way slab. Okay, two-way slab. If the dimension, keep in your mind, if the dimensions are close to each other, it's a two-way slab. Okay, so it's a two-way slab. But they have given me here one thing to be taken into account. Okay. Now you can see what's happening here. Okay, you can see what's happening here. This is my slab, and then this is my steel beam. Okay, we have a slab and we have a steel beam, and they told you that there is no connection between them. It means they have constructed the beam, or they have placed the beam. At the top of the beam, they just placed the slab. Okay, they kept the slab above the beam only. They didn't make any connection. Means there was no drilling to make sure that the slab is connected to the steel. Are we clear? They only kept it above. Are we clear? Okay. Okay. So this is one type of. This is one
Mister,
type.
no. Mister.
What no?
Again, this for
Which one? Which one, Abdurrahman?
this for
The
what?
connection.
When,
The
yeah.
connection. See, what is the meaning of connection? What's the meaning of connection? What's the meaning of connection? When I say for you, beam and slabs are connected, what does it mean?
One part together with the other part.
So it means they behave together, right? If you try to pull, the slab, the beam will try to be pulled with it. Okay? They are connected. True?
Yes.
Okay. Now what I have kept for you. Okay, what I have kept for you, I put the steel beam, and then I just placed above it the slab. Is there any connection now between them?
No connection.
Okay, I'll keep it. I'll keep it little bit simple so you don't.
Mister,
Assume
you
that
mean
I'll give you an
you
example.
mean without bloat and bent?
That depends on what type of connection. Related to the connection, that's a different scenario. You need to understand the concept. What is going to be the whether there is a connection or not. I'll just give you an example. Let's assume that we are talking about a chair. Okay, we went to a restaurant. They have two types of chairs. One chair is movable. Another chair is not movable. Okay, one chair is already fixed with the ground. Another one is not fixed with the ground. Are they the same? Which one is having connection?
The first one with the
Is it the one fixed
purple.
ground, or is it the one moving?
That's fixed. That's fixed.
Fixed. Okay. So here it says for you clearly
Yeah.
that there is no connection. It means it's like a chair kept on the ground only. They are not connected with each other. Are we clear? Are we fine?
Yes, Mister. Yes, Mister.
Others, is it clear? Okay, very good. Very good. Okay. So now when it comes to the BS code, Now, when it comes to the BS code, of course, I have already uploaded for you. I have already uploaded for you your codes in the Teams. There are few codes that you need to go and try to use. These are the ones we are going to use. Anyhow, the BS code, when it comes to two-way slab, two-way slab, has divided it into two categories. It has divided it into two categories. Category number one, which is not connected, and the name for not connected. Okay, the name for not connected, the BS code has kept it to be. The BS code has kept it to be, instead of saying not connected, the BS code has called it to be simple supported two-way slab. Are we okay? Are we fine? Okay, so if there is no connection, of course, moment will not be there. So the code has called it to be simply supported two-way slab. If there is any type of a connection, like for example, now when you construct an RCC building and you have your beam, you have your column, are they connected with each other? Do you put steel between them? Do we have steel between them? Steel and column? I mean beam and column? We have steel between them, right? If steel is between them, it means that they are connected to each other. They are not separated. Okay. If they are not connected, we call it as simply supported. If they are connected, like this scenario, for example, we call it as a restrained slab. Okay. Now to keep it very short, we have two categories: simple support and we have restrained. Okay. Simple support only will happen in two cases. Case number one, if you are having a steel slab, a concrete slab put on the top of a steel beam, there are no connections between them. If you drill the slab and put, for example, a bolt and a screw, is it going to be connected? If I'm going to drill the slab and I'm going to install bolts, so in that scenario, it's going to be connected. Okay? Both are connected together. Are we clear? If it's only placed, then it's going to be simple. If you put in your hand a paper, the paper is only kept in your hand. It is simple. If you kept a glue in your hand and then you place the paper, no, it will not slide. It will not slide. But it's going to be not good for for heavy or medium lateral loading. Sulaiman, it's not going to be falling. It will not slide. It's sitting above. It will not sustain. It will not sustain a very huge lateral load. So as this system, it's not that good when it comes to lateral system. Yes, Bushra, tell me what's confusing. Once again, I'll just give you an example so Bushra and others will understand. I kept my hand and I kept above it a paper. Okay, you will see that the paper will sustain unless it is sitting above it. It's the same example of the chair. How the chair is what you call standing in the ground. When I say it's laying above, when I say it's laying above, it does not mean they are connected. Are we clear? Returning back to the question that Suleiman has asked as well. If I keep the paper on the top of my hand, if I placed my hand, then I kept at the top of it a paper. Unless there is a very good lateral loading, that paper will not move. If I want to do a proper connection between them, for example, I'll go and put a glue in my hand. At that time, I'll go and place the paper above the glue. You see that they are connected now. The paper cannot move from my hand. My hand is not separated from the paper. If they are separated, the paper and the hand, this is simply supported. They are not connected. Is it clear? Are we fine with the example of the paper and the hand? Okay. Okay. Now, the code. If you go to the code, okay, Bushra, no problem. If it's not clear, I'll explain for you later. Okay. So now we have, if you go to the code, we have bending moment for both cases. This is the BS code that you are going to use. Okay. So we have bending moment for a simply supported case. For a simply supported case. And it's a two-way direction or two direction. Okay. Slab spanning in two direction means a two-way slab. So this is the table used in case of using a simply supported. Another example of simply supported is a precast element. Now precast elements, where are they made? Precast elements. Precast element in the factory. Okay. So in the factory, you will go and take them to the site, right? So they were not connected from the beginning. Okay, they were not connected from the beginning. The elements were not connected from the beginning. Are we clear? Okay. And then we have the restraint as well. Now for the restraint, we have two categories for the support. So once again, we have restraint and we have simply supported. Under restraint, we have two types of support. We have continuous and non-continuous. Is it clear? Are we clear? Okay. Bushra, you have understood the meaning of simply supported? Simply supported was fine. Okay. So if they are having connection, we call it to be a restraint slab. So two types. If no connection, simple. If there is a connection, we call it as a restraint slab. In restraint slab, we already discussed previously that there are two types of supports. You remember, we said two types of support. Whatever we tried to do earlier, remember we said we have a continuous and we have non-continuous. Do you all remember whatever I have said? So two categories, simple and restraint. Under restraint, there are two types or two supports. One is continuous and non-continuous. It's very simple. Now, if we go out to our BS code, okay. So this is the table that we have said is going to be for a two-way slab, but it's simple. And then we have this table. We have this table for a two-way slab, which is restraint. Can you see? Can you see this one?
Yes, this all.
So it's a very big table. Okay. It's a very big table that is having how many cases? How many cases are there? 1, 2, 3, 4, 5, 6, 7, 8, and then 9. 9 cases are there. Okay,
Mister,
so
this table come in the exam?
your BS code will be with
Or-
you in there.
Okay, then alhamdulillah.
Okay. So if we go, by the way, all the BS code will be available with you. You don't need to memorize any. Okay. Now, if we return back to our presentation, yes, yes. Even if it's not 90 degrees, even if it's not 90 degrees, Abdullah, you can use it. If you understood the concept of the slab, it can go. You can use it. And we'll see examples. We'll see different examples. Okay, let us see here. Let us see here and then we'll understand. Now, if we go and see the first case, it says for you we have an interior panel. What does it mean? What does interior panel mean? Interior, what does it mean? Interior means inside, right? Interior means inside. Okay. Inside. When I say inside, does it mean that the slab is having surrounding slabs? When the slab is inside, do you have slabs left, right? Do you have slabs on the sides when we talk about an internal? There will be, right? There will be. Okay. So from when I talk about the first type, which is interior. Interior refers to the fact that the slab is surrounded from from all sides. Okay, so now according to the what you call the slabs which I have here, which one of them is going to be like from all sides? Now, can you see here we have short and long sides? This is short side now. This is the long side. Can you see? Can you see the short and long side? Okay, very good. Now, for example, if we take this slab, we have slab here, 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 here. Do you have slabs from all sides? Can I call it to be interior? Can I call it to be an interior slab? Okay. Okay, so the best thing to do, okay, normally the best thing that I normally do with the students, I'll just draw a line for the exterior. Now, here, I'll just draw a line wherever there is no slab. Okay. So no slabs are here. This is the outside portion of the building now. Are we okay with that? So this is not representing fixed now. This is representing that this is the end. There is no slab. Are we fine? Are we okay? Okay. Now, another thing that has been given here, it says for you that this is an opening. What does opening mean? What does an opening mean? It means that there is a slab or there is no slab. We say opening. Opening, is there a slab or there is no slab? No slab. Okay. So can I say that this is discontinuous as well? This is discontinuous. Can I say like this? Because there is no slab, right? Discontinuous. Can I say like this? Because there are no slabs. So wherever there is no slab, I'm just drawing a line. Okay. Are we fine? Are you fine with whatever I've done? Okay. Now let's go for case number 2. Let's go for case number 2. Case number 2 says for you one short edge discontinuous. How many discontinuous are there? How many discontinuous? Only one that is short. So I need to see which slab is having only one short edge to be discontinuous. When I say one short edge to be discontinuous, it means that there are 3 which are continuous. 1 discontinuous, 3 are discontinuous. Right? Now let's take this one for example. Is it continuous from here? Continuous from here? Continuous from here? Discontinuous from here? Discontinuous from which side? Is it short or is it long? Short. Is it clear now that this slab, which is number 2, is called now to be one short discontinuous? Is it clear? Okay. Let's go to the other scenario. It says for you one long edge discontinuous. One long edge discontinuous. It means that how many continuous? It means that 3 continuous, 1 discontinuous. So let's take here. Continuous, continuous, continuous. Only one side which is discontinuous. Is it long or is it short? Are we fine? We are fine with the number 3? Right. Right. Number 4. Number 4, it says for you 2 adjacent edges discontinuous. Okay, number 4, it says for you 2 adjacent edges discontinuous. 2 adjacent edges, when I say adjacent, means nearby. Okay, it means one short, one long. Okay, one short, one long. If I go here, if I take for example this one, okay, As Abdullah said, normally they are going to be in the corners. Okay, but not all the corners. So here you can see there is one long edge discontinuous, there is one short edge discontinuous, and there are two continuous. Are we clear for number 4? Is number 4 clear? When I say two adjacent edges discontinuous, it means one short, one long. Once again, two adjacent edges discontinuous. Two adjacent edges discontinuous, it means that two are discontinuous and two are continuous. When I say adjacent, means near to each other, it means that one long and one short. Not always. This is what I say for you, it's not always. If I take this one, if I take this slab for example, how many discontinuous do you have in this slab, which I have written to be x? How many? Adjacent or two adjacent discontinuous. There are two discontinuous, there are two continuous. Two discontinuous, two continuous. Here if you see, this is one discontinuous, this is two discontinuous, this is three discontinuous. So it does not fit. If I take another one here, this is one discontinuous, this is one discontinuous, this is third discontinuous, it does not fit. So not always. If a typical building, yes. Here, if I take for example here, one short, one long, then we have one continuous, one continuous. Are we clear? Two adjacent edges discontinuous, it means one long, one short. Case number 5. Case number 5. It says for you two short edges discontinuous. So there are two short which are discontinuous, and it means that there are two long which are continuous. There are four sides of the slabs. Two short to be discontinuous, two long to be continuous. So we need to go to our problem, search where two are short. Where do we have two short to be discontinuous? Can I say here? Is this discontinuous now? Is this discontinuous? Is this discontinuous? So we have two short discontinuous, and we have one continuous long. Yes, Amira.
For example, slab number 4, we have two types, or we can consider it as two ways. One is to adjust continuous or to adjust not continuous edge. Which one we should take?
You should refer to the code. The code says for you both of them, but the code says for you, the title says for you, two adjacent edges discontinuous. You don't have another case called two adjacent edges continuous. It's only one case. So both of them are fine. They don't contradict with each other. Okay. If I have two adjacent edges continuous, yes. But now there is only one case of two adjacent edges discontinuous. So that's fine. Both of them are the same. Okay. Now going for two long edge discontinuous. Okay, two long edge discontinuous. Okay, two long edge discontinuous. So we are going to see where two long edges are discontinuous. Okay, where two long edges are going to be discontinuous. So can I go, for example, for this one, where you can see that this is discontinuous, this is continuous, or this is discontinuous, this is discontinuous, this is continuous, and this is continuous. Are we okay with case number 6?
Can you repeat it once again, please?
Now, if you see for case number 6, it says for you two long edges discontinuous. Now, this is edge number 1, Is it discontinuous or discontinuous? Edge number 1. This one. Is it continuous or discontinuous? Any slab? No slab. What about this one? This is short continuous. This is short continuous. This is long discontinuous. This is another long discontinuous. So we have 2 long discontinuous. Are we fine? Going for case number 7. Case number 7. It says 3 edges discontinuous. Now 3 are discontinuous. Only 1 is continuous. 1 is continuous. No, it does not require time if you practice. It does not require time. Okay. 3 edges to be discontinuous. So we'll go here. Once again, 3 edges discontinuous. 1 is 1 long to be continuous. So only 1. We need to search for 1 which is continuous. Now let's take this case. We have 1 discontinuous, 2nd discontinuous, 3rd discontinuous, and we have only 1 continuous which is long. Are we fine? Okay. Now going for case number 8. It says for you, case number 8. It says for you 3 edges discontinuous. So 3 of them are discontinuous. Only 1 is continuous. Which one? Short. So 3 are discontinuous. Only 1 is continuous. We'll go here. And this is going to be case number 8 now. For case number 8, this is discontinuous. This is discontinuous. This is discontinuous. This is the only one which is continuous. Or whatever Bushra has said. Okay. Or sorry, this is not the correct one. Actually, this is the correct one. Whatever Bushra has said. Okay. Discontinuous, 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 and this is continuous. Okay. So this is case number 8. Okay. Now the last one. The last one is going to be 4 edges. Yeah, you can have more than one. You can have more than. I'm just illustrating examples so you understand. 4 edges discontinuous. So last thing, we have a slab where 4 edges are going to be discontinuous. 4 edges are going to be discontinuous. So can you search for that slab? Can I say that this is the slab? Disconnected. 4 edges discontinuous means all of them are discontinuous. This slab is not having any connected near to it, any connected slab near to it. This is discontinuous, this is discontinuous, this is discontinuous, and this is discontinuous. Are we clear? Are we fine?
Mister, for the case number 9, why we didn't select from the second row the first one?
The second row, the first one
The
to
second
the right,
line,
second
to
row,
the,
first to the right or the left?
the second line, the first one on the top.
This one? Are you
Yes.
referring to this one?
I'm not able to see the.
The one I'm drawing in.
Yes.
Now this is the second row. No, you cannot because this is continuous.
Okay.
Okay. Now you should know, by doing that, you should know how to classify the case, because if you didn't classify the case, you can see here that the bending moment coefficient, if you remember, we talked about bending moment coefficient. You remember when we said moment is equal to beta multiplied by W multiplied by N square? Beta now is representing the values here. Whatever you see, these are the beta. All of these are betas. Okay. So if you picked the wrong case, it means that it is the wrong coefficient. It means that it's a wrong bending moment. It means that it's a wrong steel. It means it's a wrong deflection. It means that the whole question is wrong. Are we clear? That's why I have spent a lot of time explaining this one. So what I'm going to do, I'm going to give you another example where you will try to practice. You will try to practice finding out the cases, case number 1, case number 2, case number 3. Now you should know which code of this one. This is the code, the main code that we are going to use. It's BS8110 part number 1. So BS8110 part number 1. It has been uploaded to your teams. Okay. And you can see that the page number is 46. The cases are available. I'm going to give you later on. I'm going to give you one example. You can try it yourself to try to identify the cases. Okay. So one previous question I used to ask in the in the previous semesters, that they need to identify the cases. After that, based on the case, they need to find the moment. After that, they need to start designing. Okay. But if you know how to define or identify the case, it will help you a lot. Okay. Doing that, we have finished today's session. We have finished today's session. The only thing remaining for you, is your test. Your test now is going to be opening in your e-learning. You go to your e-learning. Okay. If you go to your e-learning, okay, so if you go to your e-learning and then advanced RC design, you will see that there is advanced RC design pop-up quiz, 10th or 6th of October. And then you see that the question is already opening. Okay, you can try. You have 5 minutes. We have already discussed that question in the previous session, and we have discussed it today as well. Okay. Thank you very much for listening. By the way, it will close up at 3:30. Anyhow, since I have already taken some of the time, I'm going to extend it another 5 minutes. Okay, so you can enter at any time from 3:20 to 3:35, but as long as you see your question, you have only 5 minutes to answer. You need to go to the e-learning. You need to go to the e-learning. If the e-learning is not opening for anyone, write your ID in the chat, and then I'm going to write it for you. I'm going to add you. Yes, now. Our class has finished already. Our class has finished.